simultaneously, which would require a means of communication faster than the speed of light. This made a certain famous quantum physicist very grumpy. His name was Einstein, because his entire theory of relativity was based on the fact that nothing could travel faster than the speed of light, only 86,000 miles per second. This experiment seemed to prove that things could go faster than the speed of light, which would mean his entire life's work was thrown out of the window. That's just one idea about what's going on. And that's an idea where we've got that these two electrons are separate from each other. But what if they weren't separate from each other in reality? What if there was another level of reality where those two electrons were actually the same thing? And what we're getting is two views on the same thing, a level of reality where it wasn't that these two electrons were connected, it was that these two electrons were actually the same thing. And they postulated this particular level of reality was called the morphogenic field. We might hear it called the M field. A level of reality where everything is one. Now, if you studied any ancient teachings on the planet, you've probably come across the idea of there being a level of reality where everything's one. A lot of people are saying that quantum physics is the 21st century's mysticism, and that much of what's coming out in quantum physics has been said for thousands and thousands of years before. It just wasn't proven by science. So what we're talking about here is, imagine let's say in a room you have a fish tank, an aquarium, with a fish in it. That's a fish, by the way. Again, this is why I'm an NLP master trainer, not an artist. An artist wouldn't need to tell people what the picture was of. And we had a camera pointing down that end of the tank, and we have a camera pointing this way. And in another room, we have two TV screens. Like this. And you've got two pictures of what appears to be two separate fish. One like that. And one like that. And you're looking at these two fish. Then you start to realize, actually, these two fish seem to be communicating with each other in some way, because there's a relationship between the way that they move. When this one moves in a particular way, this one moves in a particular way. It's a different way, but there seems to be some kind of relationship between the two. So you think these two fish are communicating with each other. But really, in the other room, there's two different views of the same fish. And that's what we'll be talking about with the morphogenic field, the level of reality where we're all one. Now you see a lot of examples of that. Like if you've ever been snorkeling or scuba diving, you see huge shoals of fish that, they'll be swimming in one particular direction, and suddenly all the fish change direction all at the same time. You ever seen that? Or you might have seen it on TV or in movies. Now, if we all wandered around in a group, and then one of us decided to change direction quickly, and we all did the same thing but it's in different directions, we'd all bump into each other, but the fish don't. Or you see flocks of birds flying, and they're flying in one direction really fast, and then suddenly they're off in a different direction. How do they communicate with each other that quickly? Well, one of the answers to that is the morphogenic field. And there's a number of different examples of that I'll talk to you about. So anybody here heard of the 100th monkey syndrome? Anybody here? Yeah, people heard of it. This is 100th monkey syndrome. It comes from some anthropologists that were studying monkeys on a remote island. And what they were doing is feeding the monkeys. So they fed monkeys sweet potatoes, and they dropped them on the beach. And the monkeys were going to eat the sweet potatoes. But one day, one of the scientists took one of the monkeys by the hand and taught it to wash the sweet potatoes in the sea to get all the sand off them. Which was really great, because now they weren't eating sand. And they've got this nice little sweet and sour thing going on with the salt from the salt water and the sweet from the sweet potatoes. So he taught one monkey, and this monkey, once he tried it out, taught another monkey, then another monkey taught that, until a whole series of monkeys were all doing the same thing. Strangely, some anthropologists on the other side of the planet, not connected at all, who were researching monkeys, suddenly found that all the monkeys the same time, bam, start going and washing the sweet potatoes in the sea. How does that happen? It appears that these monkeys are communicating with each other across the other side of the planet. Well, one way that they could do that is via the morphogenic field of monkeys. So there's an idea that each kind of like race on the planet, each kind of group of people on the planet, each kind of animals on the planet have a morphogenic field that builds up. So here's another amazing thing about morphogenic fields. Bees. Now, I don't think most people would think that bees were intelligent. You've just got a single bee, it doesn't seem to act that intelligently. I don't know about you, but bees, when they come into my house, can't even find the window that they came in through. Because what they do is they keep bumping into the glass. And then do they learn from it? Oh, they bump into the glass, then they back up a bit, and then they bump into the glass again. It doesn't seem to be that intelligent. But when you get a bunch of bees together, they act very intelligently. Like, I don't know if you know this, but bees in a hive can maintain the temperature in the hive to within 0.1 degrees Fahrenheit. If the hive gets too hot, bees go out of the hive, they go and get water on their fur, they can bring it back into the hive, and the other bees flap their wings like this, evaporate the water and take the temperature down. If the hive gets too cold, some of the bees block the holes in the side of the hive, and the other ones move around really, really quickly, and it increases the temperature in the hive. And they can do that and maintain the temperature in a hive to within 1/10 of a degree. That's pretty intelligent. I mean, I've been in hotel rooms which have got highly computerized air conditioning systems, and they can't even control the temperature within 10 degrees, let alone 1/10 of a degree. Now, so some scientists are researching bees. So the bees, they're in a hive. That's the bee hive, by the way, just in case you want to know. And what they did was, at the beginning of the day, the bees go out and go and do their work, collect their honey, get their pollen, all this kind of stuff. And what they did was they put the hive on the back of a truck and drove it in a particular direction, a distance of X miles in a particular direction. And at the end of the day, the bees come back and the hive's gone. So they fly around and find the hive. The next day, bees go out to get their pollen again. Scientists put the hive on the back of a truck and they move it again in the same direction, but this time they move it a distance of 1.1x. The bees come back, the hive's gone. They fly around to find it. Next morning, bees leave the hive and the scientists put the hive back on the back of the truck. They drive it in the same direction, but now they move it 1.1 times as far again. It's 1.1 squared x. Bees come back, and the hive's gone. They fly around, find the hive. Next morning, the bees leave. Scientists once again put the hive on the back of the truck, move it in the same direction, but this time they move it 1.1 cubed x. And when they got there, the bees were waiting for them, but they were pissed. Now, I don't know about you, but I don't think I could calculate 1.1 cubed in my head. That's 1.1 times 1.1 times 1.1. But the bees did. And this is this thing that can't even find the open window in the house after it's flown. Now, ants is another example. Ants appear to be very, very organized. If you've seen them when they build a nest, they're very, very, very organized creatures. Provided the queen ant is alive. As soon as the queen ant's dead, the hive goes into complete chaos. They just don't know what they're doing, they bump into each other, they go all over the place. Complete chaos. So, if you take a nest of ants, and you take the queen ant out of let's say there's a nest of ants here, and you take the queen ant out of the nest, and you put it on an aeroplane, and you fly it to Australia.